You know that feeling when you meet someone who looks just like a person you love. Same eyes, same smile, but something is off. A coldness in their handshake. A flicker of something dangerous behind the charm? That's Venus. Our neighbor our twin. And if you look past the clouds, our mirror gone wrong. Earth and Venus were born in the same cosmic nursery, almost identical in size, mass, and what they're made of. But while Earth grew forests, oceans, and eventually, us Venus became a pressure cooker from hell. Today, we're stepping into the sulfurous hellscape of Earth's evil twin and asking, what went so terribly wrong?
Ever curious, learn what you love.
Let's rewind for 0.5 billion years. Back when the solar system was still settling, it was a molten, chaotic, and violent place. Earth and Venus formed side by side, right in the sun's habitable zone. Not too hot, not too cold. It was the Goldilocks zone. Computer models from both NASA and the European Space Agency suggest both planets likely had liquid water oceans early on, maybe even for hundreds of millions of years. In fact, a 2021 study in the journal Nature Astronomy used climate modeling to show that Venus could have had temperate surface conditions, with average temperatures around 11 to 50 degrees Celsius, as recently as 700 million years ago. Imagine that, a world not unlike Earth, rivers carving valleys, clouds raining into shallow seas, maybe even life stirring in warm, mineral-rich pools. So, what changed? In a word, everything. The culprit. A runaway greenhouse effect. Here's how it probably happened. Venus sits just 30% closer to the sun than we do. That small difference meant more solar energy hitting its surface. Over time, especially as the young sun gradually grew brighter, water vapor, a powerful greenhouse gas, started building up in the atmosphere. It created a vicious cycle. More heat led to more water evaporating from the oceans. More water vapor in the air trapped even more heat. More heat, more evaporation, more vapor, more heat. On and on it went. Unlike Earth, Venus doesn't have a strong magnetic field to shield it from the solar wind. So, over eons, ultraviolet light from the sun blasted the water molecules high in the atmosphere, splitting them apart. The light hydrogen atoms escaped into space, while the oxygen either reacted with rocks on the surface or just fed into more greenhouse chaos. At the same time, massive volcanic eruptions, possibly on a planet-wide scale, were spewing trillions of tons of carbon dioxide into the air. To give you some perspective, today, Earth's atmosphere is about 0.04% carbon dioxide. Venus? Its atmosphere is a suffocating 96.5% CO. And the pressure? It's 92 times Earth's sea level pressure. That's like being nearly a kilometer underwater. You'd be crushed instantly. The surface temperature is a blistering 467 degrees Celsius. That's hotter than Mercury, even though Venus is twice as far from the sun. A bar of lead would melt on the surface. A piece of aluminum? It would be gone in minutes. And those thick, swirling clouds? They aren't made of water. They're made of sulfuric acid. Droplets so corrosive, they dissolve your skin on contact. So, you should think of Venus not as a planet, but as a cautionary tale. A warning from our cosmic twin. We have visited this hellscape. In 1970, the Soviet Union Venera 7 became the first spacecraft to make a soft landing on another planet. It transmitted data for just 23 minutes before the heat and pressure destroyed it. Then, in 1975, Venera 9 sent back the very first photos from the surface. They showed a bleak, rock-strewn plain under a dull, oppressive orange sky. It looked a bit like Mars, but far, far more hostile. The most resilient of these probes was Venera 13, which lasted an incredible 127 minutes. It was long enough to take a color photo and analyze the soil. It found basalt, confirming ancient lava flows, and even detected what might have been lightning deep within the clouds. But here's where the story gets really curious. In 2020, astronomers announced something shocking. They had detected traces of phosphine gas in the clouds of Venus. This is a big deal because phosphine is considered a potential biosignature. On Earth, phosphine is produced either by microbes or by industrial processes. On Venus, there is no known non-biological or abiotic process that can explain the amount of phosphine they observed. The discovery, published in Nature Astronomy, sparked global excitement and a lot of fierce debate. Follow-up studies questioned the data, but then in 2023, a reanalysis not only confirmed the signal, but also found phosphine near the planet's equator, where strong updrafts could be carrying material up from lower, more mysterious layers of the atmosphere. So, what does this mean? Could there be microbial life, extremophiles, floating in those temperate cloud decks where the temperature is a relatively balmy 30 to 60 degrees Celsius? Could they be breathing sulfur compounds and reproducing in tiny droplets of acid? We just don't know. But it's a tantalizing possibility. And now, after decades of being overlooked, Venus is back in the spotlight. NASA's DAVINCI Plus mission, scheduled to launch in 2029, will plunge a probe straight through the atmosphere, analyzing its chemistry all the way down to the surface. The European Space Agency's EnVision orbiter will map the planet in unprecedented detail, hunting for signs of current volcanic activity. Why are we so focused on Venus again? Because understanding Venus helps us understand Earth. If a planet so much like our own could tip into an irreversible hothouse extinction event, what does that say about our own future? Climate scientist Dr. Michael Way, who led that 2021 modeling study, puts it bluntly, Venus is a stark reminder that planetary climates can undergo catastrophic change, and that habitability is not guaranteed, even for Earth-sized worlds in the Goldilocks zone. So, is Venus truly evil? No. It's not malevolent. It's indifferent. It just followed the laws of physics and got trapped in a feedback loop it couldn't escape. But in its scorching, acid-drenched silence, it whispers a warning, and maybe, just maybe, it holds a secret. Because high above the furnace, in those swirling yellow clouds, something might still be alive, waiting, watching, wondering if we'll ever come back. Thanks for staying curious. If you'd like to dive deeper, I've linked the key studies I mentioned in the description below, including the Phosphine paper and the habitability modeling research. And if you're wondering, could we ever terraform Venus? Well, that's a story for another night. Until then, keep looking up.